All right, so we'll get going here with section 1.4, where we're going to start talking about complex numbers. You've probably heard of these before. They are called the imaginary numbers sometimes, which in my mind is a rather unfortunate name because it makes it sound like they are made up and they don't exist, when they are actually very real type numbers that you have to deal with. And there's a lot of fields in science and things like that that these are required. You cannot solve them. They're very useful in things like electronics, and they're very useful in things like even as wide-ranging as quantum mechanics. So if you go into physics or something like that, they're very useful. And so the idea here is we're going to define the letter I, which actually does stand for imaginary, I, to equal the square root of -1. By doing this, we're going to figure out how to actually take square roots of negative numbers. And so we look over here and we have this I squared then equals -1, all right? And those basically imply each other. And this little letter I has some very interesting properties. For example, if we start here with 1 over I right there, we can actually, and I need to go to the highlighter here, we can actually multiply it by I over I, right? That's just multiplying by the number 1. I divided by I is just 1. If we then take that in, we end up with, or we actually multiply those together, we get I times 1 in the numerator, that's I times I in the denominator, that's I squared. And as we saw up here, I squared equals -1, right there. So my next line is then going to be this I over a -1, which is just -I. And so what we showed here is that 1 over I just equals -I. So there it is. It has some very interesting properties, and actually I already had that written right there. 1 over I equals -I. So kind of an interesting little property of it. So let's start looking at where this can come up. So let's take a look here. Solve the equation x plus 1 equals 0. We start off by subtracting 1 from both sides. That'll give us x equals -1 right there. Okay? But what happens if instead of x plus 1 equals 0, we have x squared plus 1 equals 0? Well, we do the same, subtract 1 from both sides, and then that ends up giving us x squared equals -1. And to get x by itself, we have to take the square root of both sides like that with our little plus or minus, right? And so here we have the square root of -1. So this ultimately gives us that x equals plus or minus the square root of -1, which is just plus or minus I, because that's what we said square root of -1 equaled, was I. And so there we go. We have solved now the square root of a negative number. Now, what does this actual negative number mean? Well, what does this I thing mean? Well, that's where I drew this little graph up here. If we take and think of the real number line, like you used to draw where you had all the numbers, and you would start here in the middle, and this would be 0, and then you go out to 1, 2, 3, 4, 5, 6, and those would be positive. And then that's how you really started with a number line. You started right there, and you went out on the positive numbers all the way like that. And then eventually you learned about negative numbers, and you added this left-hand side to it, where you went to -1, -2, -3, -4. So you started off with 0, 1, 2, 3, 4, so on and so forth. Then you added the negatives. And so now what we're doing with these imaginary numbers is we're actually adding like another branch or two branches that are perpendicular to it. And we're going to go up this way. And what this is going to be is I, 2I, 3I, 4I. And you can go down -I, -2I, -3I, -4I like that, and keep going down. And this axis here that we just added, this vertical axis here, I'll highlight it in purple. This one right here is called the imaginary axis. That's why I wrote that little I right there, the imaginary axis. And then this other one over here in red, the one that you're more used to, is called the real axis. Okay? And so they're just kind of perpendicular to each other. They're coming off in a different direction. And you'll see later when we get to numbers that have both a real component and an imaginary component that this is the way that you would find them on here. It's almost like finding coordinates, where this is almost like the x coordinate. This tells you where to go in the real number line. So like tells you where to go on the x-axis, even though it's not really the x-axis. And then this number over here tells you where to go on the imaginary axis. So this is telling us go to -4 on the real axis, 1, 2, 3, 4, and then go up to 6 on the imaginary axis, 1, 2, 3, 4, 5, 6, just like that. And so then that would be the location of -4 plus 6i. That would be that number's location. Okay? Anyway, that's the idea of these kind of coming off of the real number line like that. So let's take a look here. Here's where we go to that, like what I was just talking about here, this -4 plus 6i. This is how all numbers can be written. All numbers can have a real part and imaginary part. Now, sometimes it might turn out that the real part is 0, in which case we have a pure imaginary number, just like this up here, right? And in some cases, it'll turn out that the imaginary part is 0, and that would be really what you had done entirely prior to now doing this. So if we can write any number that way. So if we have, like, say the number I, we can actually write that as 0 plus 1 times I. Then that makes A 0 and 1 B, all right, or B equal to 1. So A is the real part and B is the imaginary part, which is like what I did up here on this graph up here, right? The real part right there and the imaginary part right there, okay? So let's take a look at these numbers, and we're just going to pick out the real and imaginary parts. So here, the real part, that's this number right up here. There's the real number. There it is. And then the imaginary part, that's going to be this number right there. And there it is. There's the imaginary part. It's the one that's by the I. Over here, we have 2i. That's going to just end up equaling 0 plus 2i right there. And again, so we can match up. The real part is going to be the 0 right there, and the imaginary part is that 2, which is what I wrote down there, or the complex part, if we want to call it that instead. Here, this is the number 3, so it becomes 3 plus 0i. It's not going into the imaginary plane at all. And so the 3 is the real number, and there it goes, and 0 is the imaginary component right there, okay? Or the complex component. So that's the basic idea here. Operations with complex numbers, how do we work with these things? So if we look at something like this, you can only add real numbers to real numbers and imaginary numbers to imaginary numbers, right? They have to have the same, they have to be the same kind of numbers in order to add them. Just like if you're doing a problem in like your science class, you can't do something like, what's 5 kilograms plus 2 minutes, right? That I can't make that into something like 7 what, like, or is it even 7? I have no idea. This makes no sense whatsoever. We can't add that. And so you can't add real numbers to imaginary. You can't combine them. So what we do when we go to do an addition of two complex numbers is you add real to real, and then you add the imaginary components to the imaginary components like that. And so we'd have 5 minus 11i plus 7 plus 4i. And so then we end up with, get back to the highlighter here, we end up to the 5 plus 7, that's the real parts added together, and then negative 11 plus 4i, that's the imaginary parts, and 5 plus 7 is 12, and negative 11 plus 4 is negative 7. So we end up with 12 minus 7i. All right, so you're just adding the like parts. And to show a little example, over here of another similar thing, I did it here where I replaced I with the variable x. If you were to add these together, you could add the 5 plus the 7, and then you could add the negative 11x plus the 4x, like that. And so you'd combine things that had the same basic properties, the same type of number. All right, so let's take a look at the next one. Here we have negative 5 plus I minus negative 11 minus 6i. So I distribute this negative sign right there. So the minus negative 11 becomes plus 11, and the minus negative 6i becomes plus 6i. And so then it's just a matter of combining the like terms and adding them up. Negative 5 plus 11 is 6, and I plus 6i is 7i. And so there we have our answer of 6 plus 7i right there. All right. The next ones, there's nothing really too much more complicated going on here. This one is an addition, this one's another subtraction. So just try and follow through and do what I did there, and you should be able to get it. And then last down here, what about multiplying these numbers together? We have 2i times negative 3i. And so if you think about this, we can multiply the 2 times the negative 3 and get negative 6. And then we can multiply the I times the I and get an I squared. And if you remember from the previous page, I squared equals negative 1. So that means this I squared becomes a negative 1, and you get negative 6 times negative 1, and that's just 6. Okay? If you need to, rewind, pause that, and go through that again, but make sure you really understand that I times I is I squared, and therefore it becomes a negative 1. Here are some more ones to try. Here we're just simply distributing that 4i through, and so you get 4i times 3. Do that first. 4i times 3, that gives us this 12i right there. And then we're going to get 4i times negative 6i. So 4 times 6 is 24. And then carry that negative sign down. And then you have I times I is I squared. So this becomes, when you go to the next line, that I squared becomes this negative 1. And therefore you have negative 1 times negative 24. And we end up with 12i plus 24. And if we reverse the order, so we're writing it as the real part first plus the imaginary part, it becomes 24 plus 12i. All right, next one is just a matter of foiling here. So what we'll do is first, right, 7 times negative 2, that's the negative 14. Then you do, next one you can do is we can just do term by term. So we can do 7 times negative 3i, that's negative 21i. 7 times 3 is 21, carry the I along. Just like if you had done 7 times negative 3x, it would be negative 21x. Just carry it along, okay? And then after that, we can do the next term, negative 2i times negative 2. That gives us a positive 4 times I. Negative 2 times negative 2 is positive 4. Carry the I along. Then we have negative 2i times negative 3i. So this, we have to worry about the I squared. Negative 2 times negative 3 is positive 6. I times I is I squared. And then in the next line, we replace the I squared with negative 1, and we combine our like terms. Here we have negative 21i plus 4i. That gives us that negative 17i. And then we now have negative 6 right here, because 6 times negative 1 is negative 6, and we have negative 6 plus negative 14. That gives us the negative 20 right there, and we can bring the 17i down. So that's what we end up with right there. Negative 20 minus 17i. All right, the next one, you can look through these next ones and figure out here. This, you're just going to distribute it through like we've done before. Be careful with your I squareds. This one, again, is foiling again, so go through and do that. If you like the FOIL method, first, outer, inner, last, I personally like to just take the first one and multiply it through onto both things. And then, I guess that's first. That's the first terms, that's the outer, and then inner, and then last. So it's just basically term by term, or FOIL, whichever you prefer. I like to think of it as term by term. And then 13, this is I plus, or 1 plus I squared. So that becomes just 1 plus I times 1 plus I. So go through and do FOIL, and you should end up with just a 2i in the end. But give that a try, make sure you can follow it. Same thing here, this one, purely FOIL. I didn't even write out the actual multiplication here for you, but you should end up with 34. I want you to notice something, that these two numbers are the same, except for that sign right there. This is 3 plus 5i, and this is 3 minus 5i, right? So 3 plus 5i, 3 minus 5i. That's actually called a complex conjugate, right? Where you have the same number, but the imaginary term is negative. Those are complex conjugates of each other. And the interesting thing happens anytime you multiply a complex number like 3 plus 5i times its complex conjugate, 3 minus 5i, you will end up with an entirely real number. Do this one out and try it, and you'll see that that occurs. All right, next one would be 5 plus 4i times, sorry, 5 plus 4i divided by 4 minus 5i. That is not a complex conjugate because the real parts are different and the imaginary parts are different, even though they have opposite signs like that. That's not the same as this complex conjugate up there. So then what we have here is we need a goal, and the goal is to get rid of any i's in the denominator. So we want an entirely real denominator, no i's in the denominator. So what we're going to do is multiply the top and bottom by the denominator, but with a negative I. So that's that complex conjugate. So here we have 4 minus 5i. That's our denominator. So what we're going to do is we're going to take that 4 minus 5i and we're going to change it into 4 plus 5i, and then we're going to multiply both the top and the bottom by that 4 plus 5i. Because what we just learned in that previous problem, if you went through and did it, is when you multiply a complex number by its complex conjugate, you get an entirely real number. So if we multiply the denominator here, by its own complex conjugate, we'll get an entirely real number in the denominator, which is then what I went through and did here. I simply FOILed multiplying this by this to give me this, and then multiplying this times this to ultimately give me this down here, which ends up giving me a real number in the denominator, but of course I'll still have an imaginary number in the numerator, and so you end up with that result. Okay, and you can then go through and just start simplifying and getting rid of stuff, okay? But that's your main goal there. And so the next one I'll leave for you to try. I went ahead and wrote in the complex conjugate there. You had 2 plus 3i. So instead of 2 plus 3i, we're doing 2 minus 3i. We're just looking at that denominator, multiplying top and bottom by it. So go through and try that one and see what number you get. And then the same thing here for these ones. I'm not going to tell you what to multiply it by. I want you to go through and figure it out, but it shouldn't be too difficult. Just follow that rule that's up there. Okay, next page, radicals and complex numbers. So here we want to perform the indicated operations and write the result in standard form. All right, so let's zoom out a little bit. You can't take the square root of a negative number, but what we're going to essentially do is pull that square root of -1 out of it. So let's take a look here. We have the square root of -9 minus the square root of -49, right? Well, if you think about this, what we can do is we can say something like the square root of -9 equals the square root of -1 times 9, right? Maybe I should write this in the pen here. Square root of -9 equals the square root of -1 times 9, which is just the square root of -1 times the square root of 9, which is just square root of 9 is 3, and square root of -1 is I. All right? So ultimately, and really we could have done one more step here. We could have said this is I, and we could have left it as I times the square root of 9. But then the square root of 9 happens to be one we can do, so we can make it 3i. But basically we can, anytime you're taking the square root of a number, you can pull that negative out. So we had square root of -9, and we could just pull that negative off of it and make it an I outside the square root. So square root of -9 is just I times the square root of 9. In the next one you look, we have square root of -49, and we can just make that I times the square root of 49. All right, so we can just do that, ultimately, now that you've seen how it's done. So take a look here. Square root of -9 becomes I times square root of 9, minus, let me go back to my highlighter, minus square root of -49 becomes I times the square root of 49. Now we happen to be able to take the square root of 9, so we can just take it and make it 3, so it's 3i. And the square root of 49 is 7i. And so we end up with 3i minus 7i, which is just negative 4i right there. Okay? So hopefully you see how that's done. Now, be very careful when you're doing this kind of thing. Think about square root of negative 5 times square root of negative 5. This will equal I root 5 times I root 5, which gives you I squared times square root of 5 times square root of 5 is square root of 25, which is just 5. And then I squared is negative 1, so you end up with negative 5. Be careful. Don't do this down here. This is wrong. Don't do square root of negative 5 times square root of negative 5 is square root of negative 5 times square root of negative 5, which gives you square root of 25, which gives you 5. That's wrong. Don't do that. Be careful that you don't do that. You're going to want to take and turn it into a complex number before you actually do any combining or multiplying of the numbers. So be careful of that. This is the correct answer. That's the wrong answer. All right, taking a look at the next one. Square root of negative 18 is just I times the square root of 18. Square root of 32 is just I times the square root of 32. So square root of 18, we can't just do that immediately, but we can break it down into 2 times 9. So we have square root of 2 times 9. And then, of course, the square root of 9 is just going to give us a 3 ultimately, right? And so this other side, we have we have this square root of 32, which is just 2 times 16, and we can take the square root of 16, right? That's going to ultimately give us a 4, so that's why we're breaking it up like that. So if we come over to here, right, come over here, we end up with square root of 9 is 3, so we get a 3i times the square root of 2 minus 4i times the square root of 2, which means these are all the same, and essentially what we can do is go ahead and combine them. In other words, you could think of it this way if you wanted. You could think of it, if we added this little part here in, you could think of it as factoring out the I and the square root of 2 from both of them, since they both have it. And you could have something like 3 minus 4 times I times the square root of 2, like that. And so 3 minus 4 is this negative 1, and then it's times the I square root of 2, which is just negative I times the square root of 2. Okay? The next ones I also here left for you to try and do some practicing on. If you have trouble with it, let me know and I can tell you what the answers are. I did this one down here for you. This one you're just going to go through and distribute as you do this. So be careful with that, especially here. This is not square root of negative 12, so be careful with that. And take note that the first thing I did was bring those i's out, right? Make them complex just there. And then it's a matter of just distributing through, multiplying that first one by each term in the parentheses, and going through and solving it, okay? So there you go. Give that one a try. Make sure you fully understand it. And that's pretty much the end for this section. So let me know if you have any issues or you need anything else with it. All right? Talk to you later.